Hey folks, and welcome. It's Dag, and I'm doing this video basically by request. So a young man reached out to me. He's building a pretty big V2 rocket that's about 6 feet tall, and he wants a way to launch it without having wires run out to it. So he wants a remote onboard igniter like I'm designing for my rocket plane. And folks, if you don't know my rocket plane project, I'll put the link in the description here, but it's basically a multiplex twister that I'm going to drop from a mothership. Light the 2D engines first and then the 2C engines about a second later, and just see what it does to the once it used to be an EDF, now it's a rocket plane, but in its past life it was an EDF. But I want to dive into a little bit more of how I made this. So folks, essentially I went out and got hang on, let me turn off some of this stuff here. I went to Amazon and basically bought the kit for building, the rocket tubes for D-size engines, which are the big tubes here, and the C-size engines, which are the small tubes. These kits come with these thrust rings that basically help the tube from sliding through the bulkheads that you have on your rocket. Essentially, it comes with little couplers that you couple your tubes together. I use just regular Elmer's white glue to glue this all together. So everything you're looking at right here comes in two different kits from Amazon by Estes Rockets. One is the D engines, like I said, and the C engines. So what I did was I essentially designed in Fusion 360 these 3D parts. Now, folks, all of these parts are going to be on my Patreon in the next week. And for $5 you can join and get basically any of my designs that I've put on my Patreon, all my aircraft designs, of course, this rocket engine, all of my 3D engine designs, everything's on my Patreon. But basically, folks, oh, and if you want the Fusion 360 file, just ask on my Patreon and I'll upload it, and that way you can edit all of this drawing right here. But folks, basically what he's going to do is mount this in the bottom of a V2 rocket, but he also wants to build the igniter system like I built for my rocket plane. So basically these MOSFETs you can actually find on Amazon. This control board I had built for me by a buddy. So you're going to have somebody build you a control board that's going to send the signals to these MOSFETs to let the power go through them to your igniters on your rocket engines, okay, on your rocket motors. So I've got drawn here basically using lithium ion batteries. You could use a LiPo battery, it'd be lighter. But basically this is the way to light all 4 engines at once, or light all 4 engines incrementally. Now, you don't want to have, asymmetrical thrust, so you probably want to at least light them in pairs, If you light this one first, this one, your rocket's probably not going to go very straight. But one of the things, folks, and I 3D printed this all out of ASA. I'm going to test this later this summer once the rocket plane's done. The rocket plane won't fly till next year. Like I said, the mothership won't be done until next year. But essentially, folks, that's how I designed this. Now, he asked if it's possible to put like 6D engines on here. As long as it's going to fit in whatever rocket you're building, folks, you could modify this to basically be whatever you want. Now, keep in mind, you do want to make sure that you've got some rigidity in this. So right here, hang on a minute, folks. Let me turn this one off. So you can see these little bitty rods running all the way through this to hold everything together and epoxy it together. These are actually 1/16 inch TIG welding rods, because I do a lot of TIG welding. And these rods are the 16th that help slide through the 3D printed parts, and you epoxy it all together to give it some rigidity and strength. Because, folks, when you print on a 3D printer, sometimes you don't want to have all that infill. So basically you could 3D print this part like that on your printer, and then you could 3D print this part on your printer. Hang on a minute. And that way you don't have to use a whole bunch of supports. So that's the reason I made this in 2 different parts. You could, in theory, make this one part, but your 3D printer is going to have to print a lot of supports. So that's kind of what I'm trying to do there. So, folks, hopefully this makes sense. I just threw this together. I'm going to test it later this summer, and I'll do a video of the testing just so you all kind of see what it's doing. I think it's going to work. There's no reason it shouldn't. And the way it's being mounted into my rocket plane is going to be really, really sturdy. Now, folks, there is one thing. On certain rockets, you want to have the ejection charge, which is like a small little charge that will explode and it blows your parachute out. With this configuration in my rocket plane, I don't need it. So you either want to buy the engines that don't have a charge, the ejection charge, or I've been told by a friend, I'm going to experiment with this. He takes a screwdriver and removes the ejection charge from the back of the motor. Now, I'm not condoning that, and I'm not even recommending you doing it. But you might want to look that up because evidently a lot of people do it. I've never done it, and I'll let you know how it works when I try it. Again, folks, I'm not recommending you start grinding into the back of one of these motors. But look it up on YouTube. I've been told a lot of people do it. But again, I'm not recommending it. So, folks, one of the things I want you to think about this, though, if you're going to use an igniter like this, is you got to have a safety. And the way I designed mine was I have a physical connector that I actually connect. Once I've got all of this hot, the final connection is connecting the wires from this to the rocket engines or the rocket motors. You've got to, really be careful that you don't accidentally have a misfire. Because, folks, if you have 4 of these in your garage and they ignite, whatever you're building is going to try to take off. So please, please, please build in some type of redundancy, a physical redundancy, a physical connection that if your radio for some reason, and folks, look, I'm going to digress for a minute. When we fly electric model airplanes, we put what's called a motor cutoff switch on our radio. So when we flip the switch, and you hit our throttle, the motor won't turn. There are still people that don't do that, and they accidentally hit their throttle, and the prop cuts them. It runs into them, and you got to have that motor off or that motor kill switch on your radio when you fly electric model airplanes. Same thing with this. You need to have 2 or 3 different levels of redundancy that you cannot have a misfire. Excuse me. Number 1 is on your radio, whatever is going to send the signal, you need to have several switches to arm it. Number 2 is you want to have a physical arming where you actually plug a connector together. Okay? So I don't know how much to stress that when you have 4 rocket engines ignite, especially on this, there's going to be some thrust there for about 2.5 seconds and a lot of heat. If this, God forbid, if this was up against your leg and went off, it'd probably burn a hole right through your leg. So please, please, please be careful. And folks, this is all just for information. I'm not recommending anybody do this or even follow my methods. Okay, this is food for thought on how I did it. A guy's building a V2 rocket, wanted to know how I did it, and that's the reason I'm producing this. So thanks, everybody. Rock on. Have an awesome day. Please like and subscribe and share my videos. And I'm trying to get more how-to videos or how I've been doing this stuff on my YouTube. So hopefully you're enjoying it. So rock on. Take care. Have an awesome day. Talk to you next time. Bye-bye.